Okay, I'm going to now show you 3 different questions on calculating the moment about a line. So this is the moment of a force about a line rather than a moment about a point. Okay. Right, so this first question, I'll just label it question 1. Determine the magnitude of the moment of the force about, and in this question it's about 3 lines. So there's 3 answers. The force F about the axes X, Y and Z. Solve the problem A using Cartesian vector approach, so the vector approach, and B using a scalar approach. So that's in the traditional way you would have done it before doing vectors. So let's have a look at the problem here. We've got a force acting at this along this vector. Well, this is a force vector. And we've got this arrangement of pipes and the force acting this way, and it says calculate the moment about this X line, this Y-axis line and this Z-axis line. Okay, so first thing we do with all of these geometry questions, we write down our coordinates or position vectors of each of the coordinates we're interested in. So A is, well, 0, 0, 0, it's the origin. B is, so 4, we look at the diagram 4, Y is 3, and Z is -2. Remember to get these signs right. Getting these 3 coordinates is key to getting anything right in this question. So C is 4, 3, 0. It's in the plane, XY plane. We're going to always need some vectors joining these points, or lines joining these points. So let's start these vectors now. So AB is equal to B minus A, which equals 4, 3, minus 2. It's just the same as a position vector. AC is equal to C minus A, which will be similarly just the same as what we have C is up there. 4, 3, 0. We're going to need CB, I think. So that will just be B minus C, which will be 0, 0. And it's -2, -0, -2. Okay. So, key to this calculation about the moments about a line is this formula. So, I'm going to say moment of a force vector F about a line is, so the moment is equal to the unit vector dotted with a cross product of a so let's say unit vector in the line. R is a position vector from any point on the line to the point of action of the force, and F is equal to the force vector. So the first thing we need to do is look at for each question to get the unit vector. So in this case it's quite easy for the three parts because the unit vectors are in the x, y, z axes. So let's write this down. We'll write u, and I'll call it x for the x direction. The vector is simply 1, 0, 0. U in the y direction is equal simply 0, 1, 0, and u in the z direction is simply 0, 0, 1. So R, what is R going to be? So let's look at the geometry again. Now it's from the force, we need a vector that goes from the line to the force. So it could be any vector from the x direction, say. And so that last one I've drawn is come from point A. It turns out point A is on all three x, y and z axes. So we're going to use point A for each of the three calculations. So this R vector, so R is equal to the A, B vector. Let me know about that and draw that slightly better. It's this AB vector. Okay, so R is equal to AB. And I'm going to write for example, because it could be many other vectors, but AV is the most convenient. So we can easily write down a moment in the x direction is equal to ux dotted with AB crossed with the force vector, which we write down as ux 1, 0, 0, AB, we calculated it earlier, 4, 3 minus 2, and the force vector 4, 12 minus 3. Okay, so we expand that. That'll be equal to 1 times the determinant of 3 minus 2, 12 minus 3, which equals minus 9 minus 24, which equals 15, and we can write Newton meters as the dimensions of meters of the force in newtons. Okay, so we're going to write a similar, so that's the moment of the force about the x-axis. It's not a vector, it's a scalar. Okay, so we'll do a similar thing for my. which equals uy dotted with, again it's AB because A is on the y-axis, crossed with F. And this is then 0, 1, 0, 4, 3 minus 2 as before, and 4, 12 minus 3 as before. And this will be minus 1, 4 minus 2, 4 minus 3. And we can expand that to my equals minus 1 times minus 12 minus 8, which equals 4 Newton meters. And similarly, mz is equal to uz dotted with AB cross F 0, 0, 1, 4, 3 minus 2, 4, 12 minus 3, which equals plus minus plus 1 times determinant of 4, 3, 4, 12, which equals 48 minus 12 equals 36 Newton meters. Okay, there's the three moments of the force about each axis. In terms of scalar calculation, mx is equal to the sum of moments about each component about the x direction, and we look at 12, so we ignore we've got the force, F is equal to 4, 12 minus 3, so we're 12 times the distance, which is 2 meters, minus 3 times 3 meters equals 15 Newton meters. My is equal to the sum of my, which equals minus 4 times 4 meters minus 3 times 4 meters, which equals 4 Newton meters. Z is equal to the sum of the mz's, that's z, which equals 4 times 3 meters minus 12 times, so that's plus 12 times 4 meters, which it comes to 36 Newton meters. So these are all the same, 36, 36, 4, 4, and the 15 was on the sheet before. Okay.